A foggy morning can turn icy even when no rain is falling. In freezing fog, the danger is hidden inside millions of tiny water droplets floating close to the ground. The droplets are still liquid, but the air around them is at or below 0 degrees. That makes them supercooled, which means they are ready to freeze the moment they touch something cold. Fog forms when air becomes saturated, so it cannot comfortably hold any more water vapor. On clear and calm nights, the ground loses heat into the sky through radiative cooling. The ground then chills the shallow layer of air sitting above it. If that air cools to its dew point, water vapor condenses into tiny droplets and fog begins to form. A thermal inversion can make the setup stronger. That is when colder air is trapped near the surface, with warmer air above it like a lid. In valleys, basins, and highland towns, cold air can also drain downhill and pool overnight. If the trapped air is moist and temperatures fall below 0, ordinary fog can become freezing fog. The important point is that the droplets do not have to freeze while they are floating. Pure, tiny droplets can stay liquid below 0 because freezing often needs a trigger. That trigger is called a nucleation point. It might be a dust particle, a rough tree branch, a fence wire, a windscreen, a bridge rail, or the surface of a road. When a supercooled droplet hits one of those cold surfaces, it freezes almost instantly. More droplets arrive and freeze as well, building up a coating known as rime ice. Rime often looks white, rough and feathery because the droplets freeze quickly and trap small pockets of air. On trees and fences it can look beautiful, but on roads it can be treacherous. Freezing fog can also help create black ice. Freezing fog is the weather in the air. Black ice is the hard, thin, often hard to see ice on the ground. Bridges, overpasses, ramps and shaded roads are high risk because they cool quickly and may stay below 0 longer than nearby ground. The same process matters for aviation. Supercooled droplets can freeze onto wings, propellers, windscreens, and other exposed aircraft surfaces. Even a thin film of ice can change airflow, so aircraft may need inspection and de-icing before taxi and takeoff. In Australia, freezing fog is uncommon, but it does happen in the coldest places during winter. The Australian Alps and the Tasmanian Highlands are the classic areas, especially during cold snaps with clear skies, light winds, cold air drainage and strong overnight cooling. If you are travelling early on a sub-zero morning, treat fog as more than a visibility problem. Slow down, leave extra space, use low-beam headlights and watch for sudden changes in grip. Be especially cautious on bridges, shaded corners, footpaths and airport access roads. Freezing fog is a simple idea with serious impacts. Tiny liquid droplets survive below 0, then turn to ice on contact. That small change is enough to coat the landscape in rime, reduce visibility, and create slippery surfaces before you even see the hazard.